293. That's right, 293 is the video that we're on right now. That you go back and watch part A, and you also have already completed page 292. Have a note card. Have a note card that says vertical angle theorem. We're building up our list of vocabulary words, theorems, geometry statements that you need to have access to quickly, automatically. Maybe it's going to lodge itself up in your brain, but until then, have it on paper. Vertical angle theorem is the vocabulary word that we are focusing on, and it says vertical angles are congruent. So on your note card, write that on the back. Vertical angles, get on the camera here. Vertical angles are congruent. And this is on page 293. I'm starting to put the page number whenever I worked on that term, I'm putting it there. So I want to kind of remind myself, like I want this to be a useful study resource. Term, example, specific statements that you should make. In fact, I'm going to add in front of you the measure of angle 1 equals the measure of angle 3. The measure of angle 2 equals the measure of angle 4. I want to add detail to the back of those note card statements. I also started writing the different things that we've used. We used the linear pair postulate. So take a look at the flowchart example. We used the linear pair postulate. So I want to make sure a reference for me for the future with vertical angles is that vocabulary word. We also used supplementary angles. We used the reflexive property. We've used substitution. We've used definition of congruent angles. And so all of these flowchart statements, these reasons I should say, all of these flowchart reasons, I want to put them on this note card too, just so I can kind of see the web of connectedness start to become reality. Now, the rest of page 293 asks us to actually write the two-column proof from the previous page, from page 292's flowchart. So let me get a little reset on the camera here. Okay, there we go, there we go. Maybe like that. Okay, let's go. Using what we did, right? Using what we did or saw in observation from the flowchart proof, now we can write that up into statements and reasons. So the first statement is, I'll list it as statement 1, angle 1 and angle 2 are a linear pair. And that reason is because given. Just so that you see what's going on, I'm going to move the camera over for a minute. I'm literally taking these flowchart boxes and putting them into two columns, where the statement and the reason is the difference between what is written in just normal text versus what is written in bold text. Statement, reason, row 1. And then I'm going to keep doing them. I'm going to go back and forth here, right? So let's bring my face in so you can see me as I'm talking to you. Angle 2, or step 2, I mean. Step 2, the second box over there. Angle 2 and angle 3 are a linear pair, which also is a reason for given. Remember, we're not going to combine all of those given statements into one reason with all of these listed out. Sometimes people do that. More advanced geometry students might combine them all, but we're going to go ahead and keep them separated. One statement, one reason, one statement, one reason, even if they're the same reasons listed over and over and over again. At this moment, I'm going to say maybe you should skip ahead in the video 20 seconds, 30 seconds, however long it takes for me to finish this out. But before you just jump there, do your own work. Use the worked example from page 292 and start moving it over onto this two-column proof. Literally, step 1, put it as the first row. Step 2, put it as a second row. So at this moment, skip forward. I'm just going to write it all the way out. Maybe a little bit of talking along the way, but not a lot of explanation. At this moment, it is like writing a paper where you do your outline and then you start fleshing out the paper, the essay, the thesis, and the supporting arguments, leading to your conclusion. Man, a proof is a lot like an essay. Something to think about. All right, skip forward. Angle 1 and angle 2 are supplementary angles, typo, and the reason for that is linear pair postulate. Yeah, that's coming in on the screen pretty decently. Step 4, angle 2 and angle 3 Oh, it says for the other proof statement. Okay, I just caught that. I'm going to leave it. Who cares? Angle 2 and angle 3 are supplementary. Right, there it is again. And so step 4 is also linear pair postulate. Should I flip right now? We've got 1 and 2, 2 and 3, 3 and 4. Just leave it. 5. The measure of angle 1 plus the measure of angle 2 equals 180 degrees. Should I flip? I just need to flip it. Okay, so what I'm flipping is that it is 2 and 3. I've got that. So it's not 2 and 3. It's 3 and 4 here. 3 and 4. Because I forgot the other proof statement. So angle 3 and angle 4 are a linear pair. Angle 2 and angle 3, angle 1 and 2, angle 2 and 3. So this one needs to become 3 and 4. 2 and 3 are supplementary. 3 and 4. And then this reason, same reason, definition of supplementary angles 6. So step 6, step 6 is the measure of angle 2 plus the measure of angle 3 equals 180. And then step 6, that is also definition of supplementary angles. Step 7 says that, well, they skipped a bunch. Step 7 should be that these two angles are the same. So I'm going to go the measure of angle 3, right? That's supposed to be a 3, plus the measure of angle 4 equals the measure of angle 2 plus the measure of angle 3. Step 7 is substitution. What's on the back of this page? They just dropped the proof? But they really did. Okay. Step 8. The measure, let's see, 3 is in 2 spots, so the measure of angle 3 equals the measure of angle 3. That's reflexive. This is not good. Dot, 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 huh? Oh. Interesting. So they say right here, they don't use, they take this out and they say all of this is congruent supplements. I'm not going to do that. I'm going to keep going forward. 9 means that the measure of angle 2 equals the measure of angle 4 because of subtraction. Dot, dot, dot. Hey, hello. Hey, if you're still watching, like, stop. Pay attention. I got to talk to you for a minute. Whoa, whoa, whoa. Okay, maybe you're still here. Thank you for watching all the way through. But if you're not, like, cut, like, watch, like, oh, let's do this one with the video. Whoa, whoa, whoa. Okay. Sorry. Thanks. Minor freak out moment. And this is because this one, I forgot to read the word other prove. And so you might be looking at yours and comparing it to mine and realizing that, what? I wrote down 1 and 2 and I wrote it in pen. Oh no, it's supposed to be for the other prove statement, which is angle 2 is congruent to angle 4. So in order to fix this and make this work, I went ahead and I swapped or switched around the appropriate angles for the other proof statement using the other given and then the structure of the proof. And then as I was working through it with the teacher's manual by my side, they actually skip steps 8 and 9, and they jump right to one of our other vocabulary words. Let me see if I can find it here. Segment addition, linear pair, definition of right, subtraction. We use subtraction property of equality. Definition of right angles, right angle congruent. This one, they use congruent supplements because congruent supplements on page 291 means that if these two angles are the same, and these two angles form a linear pair, and these two angles form a linear pair, then these two angles must be the same. And so they actually skip out, pull away from the steps 8, 9, and 10 of what the other problem did. And they just go right away from saying, look, they both equal 180, they must equal each other, congruent supplements, and they make the proof shorter. That happens all the time. Minecraft reference is like saying you're going to do it in 3 less redstone than someone else. This is where geometry has that same logical structure. Can you do something with a shortcut or a shorter step that still is logically right, but doesn't require the same depth of detail? And we like theorems because theorems do that for us. Theorems let us take some larger chunks of logic away. How does the 2-column proof compare to the flowchart proof? Statements, reasons, step 1. Statements, reasons, step 2. If you notice, the statement that uses linear pair becomes a reason later on. So like if you want to say there's a flowchart, there's the flowchart. Linear pair for 2 and 3 becomes the reason for what we do with 2 and 3 later on. So the flowchart is still visible in the 2-column proof. A statement becomes a reason, and then you use that reason to justify another thing, which is why it is so important that you are working on developing your card stack, your deck of cards that have all of our vocab words, so that when you see linear pair postulate and it tells you on the back to use the word supplementary, that automatically starts to give you the roadmap of what you need to do to solve these problems. Videos are long, I understand. This is geometry. This is geometry at its toughest, at its finest. You've got this every day. Do a little bit more, get a little bit more understanding under your belt, and it will all add up. Thank you for watching this video. Activity 5 is next. It's on page 294. I encourage you to flip forward and see what's up with that. Thanks.